Now let's go to linear differential equation. So this is in the form of linear differential equation. As you can see, linear differential equation characterized by two: the dependent variable y, and all its derivative are of the first degree. That is, the power of each term involving y is 1. So each coefficient depends only on the independent variable x. So when we let n is equals to 1, we have this equation: a1x dy dx plus a sub 0 xy is equals to gx, which is, so we divide a1 x, so we have this equation: dy dx plus pxy is equals to the function of x. So this is our general form of linear equation. So now let's go to the problem of linear equation. So first, find the particular solution of the equation which satisfy the indicated condition. So x squared plus 1 dy, which is equals to x cubed minus 2xy plus x dx, which is the initial condition of y is equals to 1, which means that x is equals to 1 and y is equals to 1. So we multiply dx, we have x squared plus 1 dy dx equal to x cubed minus 2xy plus x. So we have x squared plus 1 dy dx. Transpose this to the left side, so we have plus 2xy equals to x cubed plus x. So we divide this both sides, so we have 2y dy dx plus 2x x squared plus 1 y is equal to x. Factor this out, so we have x squared plus 1 x squared plus 1 cancel out, this becomes 1. So we have dy dx plus 2x x squared plus 1 y is equal to x. So now notice that this is in the general form of this one, in general form. So first thing to do is, I have already listed the, so no need to memorize the formula. So I have here the list of how to solve the linear differential equation. First thing to do is put into the form of dy dx plus pxy is equals to fx, which we already did, dy dx. So this is in this form, general form. So second is find the integrating factor v is equals to e to the power of px, which px is here the function of px dx. So now we have to find the integrating factor. So the integrating factor is v, which is equals to e to the power of, these are px, so 2x over x squared plus 1 dx. So we let u is equals to x squared plus 1, so we have du 2x dx, so du over 2 is equals to x dx. So we have now e to the power of so this 2 will be cancelled out, so e to the power of 1 over u du, which is equals to e to the ln u. E to the ln u is equal to u, so substitute u, which is equals to x squared plus 1. So this is now our integrating factor. So now, next step is multiplying this equation both sides by the integrating factor. So now we multiply this to the general form, this equation, multiply this to this equation. So we have x squared plus 1 dy dx plus 2x cancel out, then 2xy is equal to x squared plus 1. So now this now we multiply the integrated factor. So next step will be this form, the integral. We have to integrate this both sides. So next thing to do is this dx, the integrating factor here, 2x plus 1 times y is equal to this. So we have x squared plus 1. Integrating both sides, we have x squared plus 1, y is equal to, so we let b is equal to x squared plus 1. So we have dv is equal to 2x dx, which we have dv 2x dx. So we have here a 1/2 integral of v dv, so which is equal to the 1, which is equal to 1/4 b squared plus c. Substitute v, so we have 1/4, substitute v, x squared plus 1 plus c, v squared plus 1 y. So here we have to get the y. So y is equal to 1/4, divide this here, so we have 1/4, and x squared, this squared, sorry, so x squared plus 1 plus c x squared plus 1 negative 1. Negative 1. So now, since we have the initial condition of y1 equals to 1, which is y1 is equal to y is equals to 1 and x is equal to 1. So now we have to substitute this into this general form of solution. So y is equals to 1 is equal to 1/4, 1 plus 1 plus c, this is equals to 2, negative 1. So by mathematical manipulation, this becomes 1/2 is equal to 1/4 2 plus c 2 negative 1, which becomes 1/2 c over 2. So our c now is 1. So this c, substitute this in this equation so that we can get the particular solution of the equation. So now we have, so our y now is equal to x squared plus 1 over 4 plus our c is 1, so 1 over x squared plus 1. So this is now our particular solution of the linear differential equation.